All right, today we're covering polynomials. Homework is page, you're doing section 5-9, page 242. 1 through 57 on. You're going to do 59 through 62 all, and 69. All right, so here we go. We've learned how to multiply a monomial times a binomial. We've been doing that. That's just distributing, right? So this would be 3 times x is 3x, and 3 times 4 is 12, right? Pretty easy. You don't need to write this, just kind of an introduction. 2a times a, what is that, Rashmiya?
2a times a would be 2a squared.
2a squared, and then it'd be 2a squared, and then what kind of 10?
Negative 10.
Negative 10. All right, Michael.
Negative 10a?
10a, yes. I am tired today. That's good. That's okay. I want you to correct me. Michael, right here. Michael, 6k, it's like k to the first, right? Times 2k squared, what is that?
12k.
12k to the what? Third. And 6k times 4k, the other Michael.
24k to the second.
What sign? Plus or minus? Plus 24k to the second. And then my third one, 6k times negative 3, Olivier?
Negative 18k.
Good. And we're done. That's multiplying a monomial times a binomial or a trinomial. So now what we're going to do is really go and start using that distributive property, that same distributing property, and this time we're going to multiply a binomial times a binomial, okay? It's the same thing. It's just double distributing. So when I distribute my k, I'm going to do it in 2 colors. My k, my x. I'm going to multiply x times 2x is what, Trent?
X
Times 2x.
times 2x equals 3x.
No?
2x to the second.
Good, because remember, we multiply the coefficients, we add the exponents. 2x to the second, right? And then I have to multiply that x times negative 3. What would that be, Boeing?
Negative 3x.
Negative 3x. Okay, you can write this one, this example. And now I'm doing 5. I'm going to do up top 5 times everything in the other. 5 times 2x. Let's go, Lucas Wine.
10x.
And notice as I'm doing, I'm writing the arrow. Is it positive or negative? Positive 5 times 2x is positive 10x, you said. And now I have to multiply the 5 times negative 3. Ellen?
5 times negative 3 is negative 15.
Okay, do I have any like terms there?
Yes.
What are they?
It's negative 3x and 10x.
Good, and that makes?
That makes 7x.
Okay, so I'm doing plus or minus. Is it positive or negative?
Positive.
Guys, you got to remember your signs because that becomes your connector.
Minus 15.
Okay? So all I'm doing is double distributing. One more time. I started with the x and I multiplied it by 2. I started with the x and I multiplied by 3. Then I multiplied 5 times 2x and 5 times negative 3. Are there any questions on how we double distribute? Caleb?
It's not a question. There's like an acronym for that.
Yes, there is. Okay, what is it?
First, outer, inner, last.
That's right, and we are going to learn that today. That's called FOIL. When I was a kid, I learned to FOIL. Okay, however, you will not have teachers that are younger than me will not be using it. They really are anti-FOIL. And when we get to the end of this lesson, I'm going to show you why. But people like me, and you do need to know what it means because you may have some old guy teaching you, in a couple of years in high school, and I'm sure he's going to be using the term FOIL because that's how we learned when we were in school. So there's also another way right here where we can do, they're just going backwards with the other one on this. The vertical method where I line them up, my 2 polynomials. Are you with me? And the first thing I do is watch this. Just watch so you know how I get it. Negative 3 times 5 is what? And negative 3 times x is what? 2x times 5 is positive 10x. And 2x times x is 2x squared. And see how I line them up? Then I get 2x squared plus 7x minus 15. So vertical method, double distributing. Yeah.
Can't you just multiply x by 2x minus 3 and then multiply 5 by 2x and x times negative 3? Like,
That's exactly what I'm doing over what I did the first time.
yeah, but then what you could you don't need to make it take as much space because you could just draw a line for 2x and negative 3 to x, but then you draw a line.
Well, I'd like to see your arrows the way I did it the first time.
Yeah, but and then you just draw an arrow to 5 times 2x and an arrow to x.
Well, I want to see the steps, the work. I don't want you doing it at this point mentally. I want to see the arrows drawn. Okay, now I'm going to show you some tricks by the end where you're not going to do any drawing and there's no work involved. Okay? But right now, I want to see you drawing your arrows and doing the double distributing. When you have coefficients of the variable and it's mixed and different, I wouldn't do the shortcuts. You just fall back on double distributing. That's your fallback, okay? So you're practicing. Okay, everybody do this one. Go. Pause the recording. Give me a thumbs up when you're done. X squared plus 9. Perfect. Okay. Did anybody get anything different? Yeah, these are all the tutor kids, right? Do you have a tutor? Do you have a tutor? You have a dad. He's not your tutor?
No, I did.
Okay, Boeing, what do you have?
X squared plus 6x plus 9.
Okay, how many people have x squared plus 9? Let me see, show of hands. X squared plus 9. Let's see what the majority is going with. How many people have the first one? Raise your hand high so I can count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, how many people have x squared plus 6x plus 9? Wow, it's pretty split, huh? Okay, what do you guys, how many people want to change either from what they originally started? Okay, so let me see. One more time, you can make a change to think what you think it is. Okay, who believes it's x squared plus 9? Raising a hand. Who believes that it's x squared plus 6x plus 9? Okay, so why did you guys all change to that? Oliver. What's making you change? Give me a reason you're changing, a mathematical reason. Patrick.
Well, because x plus 3 squared would actually be x plus 3 times the quantity of x plus 3.
When you are squaring a binomial, if I expand it out, it's x plus 3 times x plus 3. I heard Miss Sophia already say today, we do not distribute exponents. Now, it's different when you have like 5x to the third and then you have a power, right? In that case, it's only a monomial. Everything in there is squared. But we're not distributing it over a plus sign. We do not distribute exponents. You have to expand it. So when you expand it, it should not be x squared plus 9, but that is a common mistake. In fact, you'll see right here. Can you stop talking? You'll see that as we do it, I don't like to do it vertically. I mean, I would just do that times that, x squared plus 3x plus 3x plus 9, x squared plus 6x plus 9. All right. Does that make sense? So be careful with that. That will be a common mistake that will happen the rest of the year. We do not distribute exponents. Connor,
Yes.
is this clear?
Yeah.
You got the right one. It's enough to like not be able to figure out. Okay, pause the recording and you try this. Number 1 should have been 4x squared plus 20x plus 25. Number 2 should have been 9x squared plus 24 minus 24, no, plus minus 24x plus 16. Minus 24x, 9x squared, minus 24x plus 16. All right, so FOIL. I'm showing it to you. Now, I need you to write this down. Because when you make a mistake, Caleb, stay present and stop harassing. Zip. Oh. Okay, I need you guys to take notes here. Sorry. I didn't mean Caleb stop harassing. The neighbor stop harassing. Okay, so the product normally of two binomials is usually a trinomial. For example, when I multiply this, I get a trinomial, right? Now, I need you to write this down. When I multiply two binomials, I get a trinomial. The first term is it will generally have a quadratic term. This is called a quadratic. You should be writing while I'm going. A quadratic term is squared. The second term is what we call a linear term. It's to the first power, right? Remember we used to do 5x plus 2, y equals 5x plus 2, we got a line. And then the last term is called a constant term. So when you make a mistake, I'm going to need you to know what I'm talking about. All of this should be written down. Oops. Okay, so did you guys get that?
No.
Pause it and take the note. I'm recording now. All right, so you need to have all that. Now, I'm going to teach you to FOIL because this was the old method. Basically, it's the same thing as double distributing. But the acronym stands for, watch my PowerPoint for a minute. Everybody stop writing. It stands for first, outer, inner, last. Look at the first. The first term of each binomial. That's the last term in each binomial. The outer term are the furthest two terms from each other. And the inner term are the two closest, almost touching. So when we're doing this, we multiply our two first terms. X times x is, everybody? X squared. My outer terms. My inner terms. And my last terms. Now, these are like terms, and they come to negative 2x. So you'll likely have when you're multiplying a binomial times a binomial, you're going to get an outer and inner term. Guys, this is the same thing as double distributing. X times x is x squared. X times negative 5, isn't that the outer, is negative 5x. 3 times x is plus 3x, and 3 times negative 5 is negative 15. It's the same thing. Do you understand that? But Mr. Chides, all the other younger teachers, Miss Boone, they don't like this because it only talks about binomial times binomial. If you have a trinomial times a trinomial, we can't use the term FOIL. That's why the younger teachers don't like it. But people my age and older, we grew up with this. So x squared minus 2x minus 15. All right, are you guys good with FOIL? Okay, I'd like you to FOIL the next one. Go. Pause the recording.
Plus 9m plus 18.
Perfect. Oops, question. Perfect. So now some of these, is there anybody that didn't get that? Because we want to figure out why you're not. So we're double distributing, or you can call it FOIL, whatever you want. But if you have another teacher next year that doesn't like FOIL, don't use FOIL. It's a double distribute. It's when you have binomial to binomial. Now, I'm going to do something, and I want you to see if you can find the pattern. Okay? Raise your hand when you see the pattern. Raise your hand if you see the pattern. Okay. Rashmi, are you seeing it? Okay, how come your hand's not up? Leah, are you seeing it? Okay, so I'm starting with Leah. Where do you think I got this 11 from?
From 7 plus 1.
Right. So it's the sum. Okay, where do you think I got the 28 from?
7.
Good. Where did I get the 10 from?
8.
Where did I get the 16 from? Okay, do you see the pattern? So, let's talk about it. The middle term, the linear term, yes?
It's the sum of the products of the two terms in every parenthesis.
Okay, the coefficient of the linear term will always be the sum of the last two of the numbers, right? And what about the last term? Somebody else. Last term, Boeing.
The product of
That is the product of the last two. Does that make sense? Negative 10 times, oh, that shouldn't be right. I did it wrong. Negative 10 times 6 is negative 60. Right? That makes sense. Yes.
And so the variable for the middle term, you just put with
Is whatever the variable is, if it's the same. Now, when do things get a little bit different? Notice my last term is going to be what? When my product, it's going to be out of order. So this is going to be 2 times 7 is 14. So my constant term is here. This term, my m squared, is going to be here, and it's going to be negative, right?
Yeah.
Now my middle term, it's the sum. But be careful. It's the sum of positive 7, negative 2. So double check yourself. You can FOIL it. Your inner and outer term come from both of these. So negative 2, positive 7 is what? What is it, guys?
5.
Positive 5 or negative 5? Positive 5 m. My linear term is this. So this is where we go. Try the next one, number 10. Go. Yes.
I just have a question. Can you just switch the order around?
No, leave it. Leave it the way it is. And you can double distribute. You don't have to do this by the method. You can just double distribute. Okay. All right, let's check. Oh, I didn't even have answers there. Jeez. So let's do one more. I want to do one more. I want to do one more. Be careful here. Now, these are a little bit different. Are you going to be doing it's easiest, like, let's just FOIL it out. First, what is it? 2x squared. Outside. 12x, 3x, and then I have plus 18, so it makes 2x squared plus 15x plus 18. Okay, does that make sense? So with these, stop. With these ones that have like leading coefficients in front of the variables, I don't know that I'd use the quick method, Just double distribute it out. Yes.
Well, there is a pattern.
What is it?
Well, let me see. Oh, so the product of the inner terms plus the product of the outer terms is the.
You mean the sum?
Yeah,
Right, that's what I did here and here. So it's easy to do. Square the first one, multiply the last. You know. I see what you're saying. So what he is saying. Okay, so what they were saying before is I could square the first term. I can square the first term. It's 4x squared. I can square, right? I mean, it's 2x. I can multiply the last two, which is 18, and then the inner and outer will be plus 3x plus 12x. 3x plus 12x makes plus 15x. So that's what he was talking about doing. So it'd be 2k squared minus 35, and then inner is negative 10k, and outer is negative 7k, negative 17k. That's what rowing was talking about. All right, that is the lesson for today. We will see you tomorrow. Please, when in doubt, double distribute it out.